Okay, all right. So in this example, it says in the year 2000, there were 8.7 deaths per 1,000 residents. All right, and in the United States, I'm not going to try to read this number. All right, but there were that many residents in the U.S. during 2000. We want to know how many people died that year. Okay, so let's start with a ratio we know. We know that there were 8.7 deaths per 1,000 people. Okay, all right, and so this is deaths per total people. And we want to know if the population of the U.S., all right, was that number in 2000, how many of those people died, okay? So I'm going to go ahead and write that number down. So 281,421,906 residents. Cool. All right. And if we're trying to find out how many total people, I'm going to put X on top. Okay. And so then now if you cross multiply, guys, what you're going to find out is 2,448,371 people died, all right, in that year. That's sad. Okay. All right. So we're now going to come up and we're going to talk about properties of proportions, okay? So it's not going to actually be like true definitions, okay? So this one's going to start off with like if A over B is equal to C over D. Okay. So what we're looking at is how can we rearrange these proportions so that they're still true, okay? So reciprocal, remember what that means is you could flip the fractions. So that's essentially what we're doing. So we're going to do B over A is equal to, so we have B over A is equal to D over C, okay? So the way to double check to see if these are okay, all right, if like the truth value stays, is if you did cross multiply these two, once you get AD is equal to BC, and then if you cross multiply this as well, all right, once you still get AD is equal to BC, that's how you know, all right, that those two proportions are the same, that those two proportions are going to be equal, okay? All right, so the interchange means property says this time if you have A over B is equal to C over D, then, all right, now here's what I want you to look at. Do you see how A and C match up and B and D match up? So that's what this one is saying is you could have A over C is equal to B over D. And once again, double check to make sure, all right, that holds true. So if I cross multiplied and you got AD is equal to BC, all right, would I get AD equals BC here? You would. AD is equal to BC. So that's how you know, all right, that those two fractions are the same, okay? Now, the second example, there's not a second example for reciprocal, all right? The second example for interchange is actually going to look a little bit different. So we're going to start off with, once again, if A over B is equal to C over D, then, and you can do different variations of this, but what if I did something like A plus B over B is equal to C plus D over D. All right, look at the pattern. Do you see how from the hypothesis to the given is just doing numerator plus denominator over denominator, and then numerator plus denominator over denominator? As long as that pattern holds true, all right, for both sides, then it should be fine, okay? So let's apply this. So in example 11, it says use the properties to answer the following questions, okay? So it says if A over B is equal to 6 over 5, then 5A is equal to 6B, because it's just cross multiplying, okay? Next one, if A over B is equal to 7 over 11, then A over 7 is equal to B over 11. Next one, if A over B is equal to 2/3, then B over A is equal to 3 over 2. Okay? For D, if C over D is equal to 9 over 4, then C plus D over D is equal to 9 plus 4 over 4, which is technically 13 over 4. Okay? All right, last one. If A over B is equal to C over D, then A plus B over A is equal to C plus D over C. Okay? All right, that's it for section 7.1. A lot of stuff in here is review, all right? But just let me know if you have questions. Bye.